chapter 4. Maybe near the end of class today. Okay, so we'll see if we can get there. Now, what I gotta do though for a recap is this. Part 1, we're talking about polynomial functions. We know what one looks like. Can someone tell me, before I jot this down, it says write, no, I'll throw that question at you. Write a polynomial function satisfying these constraints or conditions. Write a polynomial function satisfying these conditions. So we'll start out with that. Now, if I jot down what we'll give you for the constraints or conditions, can anyone tell me what is the domain for a polynomial function? I don't care what it looks like graph. If it's a polynomial function, what for sure, if you're asked to find the domain, must the answer be? You're given a polynomial function, and they ask you, what's its domain? That's all real numbers. That's one other nice thing about polynomial functions. The domain's always all real numbers. With that said though, I'm going to write a polynomial function that will satisfy these conditions. Guys, I have these conditions to look at. First, I want the degree to be a 4. The degree is going to be a 4. Secondly, the zeros are given to me like this. I've got 3 subtract 2i, and I've got 4, which is going to be a multiple answer. It's the multiplicity of 2. And here, a third constraint or condition satisfying this, p of a negative 2 is supposed to give me a 6. Definitely gonna have something like that if we was on Wednesday. We put all this together and try to come up with what polynomial function, guys, does this describe? Now, degree 4, zeros, 3 subtract 2i, 4 multiplicity of 2, and also I want p of a negative 2 to be a 6. Now, if you'd like to think that p of a negative 2 is equal to 6, it's saying this ordered pair belongs to the function. That's all it says. And if I graph it, that point should be on the graph. Now, how are you going to get a start? I need some help. What would you do first? Based on the information given, how would you get a start on attempting to find this p of x to satisfy these conditions? Well, I would tell us on Monday. What we're going to do to get a start? We're going to look at the zeros. And my zeros here are 3 subtract 2i. That's interesting, because I got to come up with a factor that would give me 3 subtract 2i. This one's not going to be too bad. 4, multiplicity of 2. So guys, if I want to start with that, please tell me, would that be written in factored form like that? Does that show I would get 4 twice? The multiplicity of 2. By the way, as I write this out, there might be a coefficient other than 1 out front eventually. I don't know yet. So I'll make a place there for that coefficient. Now, can anyone be clever? And Isabella, I think you're the one who gave this to me last time. 3 subtract 2i. Be very careful. How can I write a factor that ensures 3 minus 2i is going to come out as an answer?
X minus 3 plus 2y.
Beautiful. Tell me x minus 3 plus 2i, professor, you set that equals 0 and solve for x, get the x by itself, get 3 minus 2i. Now at this point, the degree is supposed to be 4. That indicates there should be 4 zeros. My zeros listed are 2 here. Let me do this. I got 3 minus 2i, 4, and a 4. That's what I have right now. I should have 4 zeros, not 3. Now, can anyone tell me what you think the one that's being left out on purpose is, and that should act as my fourth zero?
3 plus 2 I.
Let me get
3 plus 2 I.
3 plus, so it's gonna be 3 plus 2 i's. I'm gonna put this in real quickly with her suggestion. So there's another one, given, and they come in pairs, and I'll tell you what that theorem is from the handout. Now though, let me get this out of the way first. With that 3 plus 2i that she gave me, be careful. How would a factor look to give you 3 plus 2i? Isabella gave me this one for the previous one. Now I want a 3 plus 2i to come out. How would that be written? Isabella, you want to help me out again?
X minus 3 minus 2.
Gotta be. Gotta be. And right now, that's a good start. Real good start. So my 4 zeros. Now, you guys who are looking at those handouts I gave you, or going through the book and looking at your work, the theorem is, and I think it's not one of the handouts, I think they call it complex conjugates theorem. I'll use them in that order. And all they're doing, when you look at that on the handout or from the textbook, is if A plus BI is a 0, takes that form, A plus BI. My original 3 minus 2i or 3 plus 2i takes that form. Automatically, no question, you don't have to do any testing. Another 0 must be this one. So it takes that form, automatically there's another one without additional testing. And they are called conjugates of one another. And they're complex numbers. I see the I in there. So guys, watch out for that, and just in case. Now, it looks good. I got the zeros out set up, I think. Now, I've got this right here to worry about. All you guys at this point, if you should multiply this mess out, which we're not going to right now, does everyone see it is an x to the fourth for the first term, so the degree is 4. So I've satisfied that constraint. My zeros are in there, thank goodness. Now this, p of a negative 2 is equal to 6, or negative 2 comma 6. That tells me at this point I can say, hold on, if that belongs there, then you can say 6 is equal to a, and replace all those x's by negative 2. I gotta be careful myself doing all that. And negative 2 here. If I placed all that in there correctly, guys, it looks like, make sure I got everything copied down right here. Is that true, guys? Do I replace all the x's by negative 2? Yes, no? Okay. Woo! Let's see if that's gonna work for us. Okay, let's do it. Now, replace all the x's by negative 2. The other side is 6. That came from this. What do they ask me to do at this point when on the quiz Wednesday, I give you that additional information, I'll give you something like this at the end. What am I asking you to do now to find? You gotta find A. We wanna know what that leading coefficient is. Now, the way I place that negative 2 in there is a little awkward right now to multiply that mess out. This is really awkward. My students can do it, but it's awkward. It might be wise if I ask that to go back and say, Professor, I'm gonna take this right here and clean that up and then put the negative 2 in there. Maybe easier. Now guys, when I say clean this up, do this for me, please. Sort of group. I know I have to group like this, and I can make this take the form of A plus B times A subtract B. And we all know from middle school that product is this. Just trying to clean it up a little bit. And in my case, the A is x minus 3, so this is x minus 3 squared. Subtract B, B is the 2i, and that's 3 squared. Is that true? Clean this up, and I am going to clean this up nicely here. Guys, this expanded out is x squared, subtract 6x plus 9. Subtract on the end, I will call it right now 4i squared. recall what I squared should be equivalent to? -1. So if I go ahead and simplify this further, replace I squared with -1. Guys, watch my math here, my signs. I think you're going to end up with x squared minus 6x plus 13. Please check and see if that is reasonable. If it is, I would prefer to, here we go, rewrite my function up here, p of x, as this, a x minus 4 squared, leave that alone. Rather than all this mess, it might be better to call it x squared minus 6x plus 13. And then do this business to it. -6 over 6, 6. Put that, leave that A green. And all I'm doing is replacing that x by -2, which will be a little bit easier this time. Let me use my colors here. And of course, -2 down here. Squared. That's 6 times -2. Looks like I may end up with large numbers. I gotta watch my math here when I get to it. Plus 13. I think I replaced all those x's by -2, did I? Okay, if I clean this up, guys, I got 6 is equal to, now don't let me mess up. 6 is equal to A, I'm gonna grade. I know this part right here, you know this part right here is -6 squared. That's 36. This, I know is 4. This is 12. And it looks like that's 13. For goodness sakes, don't let me mess up here. Is that true? Add them up, that's what, 16, 13, 29? Is it 29, guys? I think. For the end part. Try and solve for A. I would like to avoid, if I can, I may not be able to do it though, rather than multiplying this out, which you could. 36 times 29, get a big number. You're going to eventually divide, so without multiplying that out, I'm going to leave it in the raw form you see right now. And say, well, eventually I'm going to divide this by that, which might, in this case, I see something happen that may help me. These, of course, will cancel. Leaves the A. I could cancel 6 and the 36 get a 6. Oh, it did help. So it's going to be 1 over, now that's a little bit better, 6 times 29. 174 is equal to A. Final response? Where am I? Yes, we found this. A. So guys, you can write this down as P of X is equal to, Michael tells me that's 1 over 174, I think it was. X minus 4 squared. No problem. And then I'd say leave the i's. It's written like this. And x minus 3 minus 2i. If I say no, don't leave the i's, go down to the green. And rewrite as P of x is equal to, again, 1 over 174. That stays the same. X minus 4 squared. And then x squared minus 6x plus 13. And there's the equation for the function. Is that making sense?
I have a question.
Go ahead.
How we get the 13 in that part? And it's square minus 6x plus 13.
Okay. Are you looking at this right here?
No, lower.
Lower?
Or the right side.
Oh, here.
Yeah.
Okay. In the green.
Yeah, so I squared.
I is square root -1. By definition. I think I know what you do. We know that I is square root -1. If you square it, you're going to end up with I squared is equal to, the square root drops off and leaves you that. So if I see an I squared, put a -1 in there. Perfect placement. Does that help? Okay, so I squared is equivalent to a -1. look at the board space it took on this one problem. Now, you guys with me at the 4 o'clock session, you know what I might ask you next after this. You've gone through all this, you're trying to be careful as you can. You're saying, Professor, what else are you going to do on this quiz? Because this quiz looks demanding already. I'll make you sketch the graph. Give me a quick sketch, the best you can, of what this graph of this polynomial function may look like, and give me a sketch. And that means you're going to look at the zeros, touch, cross, end behavior, and all that business. And since I'm talking about that here, let's see if I can do that. And see what type of a sketch would I accept here on this. You guys, this one may not be too exciting, we'll see. My x-intercepts, my zeros. What are my real numbers here to be used? Oh my goodness, let's have one. Let's have one x-intercept, where is it? Where's my x-intercept? I have only one. Where's it located? 4. The other 2 are imaginary. They cannot place imaginaries on this grid. So guys, if I go out to 4, do what I need to do here. Now this is going to look strange. This is my only x-intercept. Oh wow, strange. Let me get my y-intercept out of the way. The y-intercept, if you go through and replace x by 0, put it up here. You're trying to find this, p of 0. Guys, if I go through and replace all the x's by 0, probably would be best to put it in that form up here. Oh boy, this could be a mess. You're supposed to replace all the x's by 0, aren't you? So we get 1 over that crazy 1 over 74, 174. And then I'm replacing the x by 0, so 0 subtract 4, oh my goodness, it's negative 4, you got squared, that's 16. Mr. Park, let me call you help here. Replace these by 0, the x's, and you end up with a 13. Did I put the numbers in correctly? Mr. Park, help me out, please.
Yeah.
I would not do this, I don't put big numbers on the quiz, but multiply this mess out and see what it is close to. 16 times 13, then divide it by 174, just out here, guys.
1.195.
1.19?
Yeah.
So the y-intercept is going to be roughly 1.19. Is it negative or positive?
Positive.
Positive. It's up here somewhere. 1, 2, it's in here somewhere. That's what you tell me, right?
Mm-hmm.
Okay. Now, what else should I take note of on the graph? The touch, the cross, the end behavior. Let's get the end behavior out of the way first. End behavior on this graph. Just abbreviate here, guys. You got to answer 2 questions for me. You got to find the limit as x out on the right is going forever of my function. And also you got to find out what's going on the other end, in behavior, on the left, written as x is approaching negative infinity on the left of this function. And so I want to tell me what does the answer to those 2 depend upon. What's that depend upon? Am I going to look at the entire mess over here, or what's the mess? Mess is here. Am I going to go back to the entire mess over there and expand more and look at it? No, it all depends on what? The first term. The first term of the polynomial function determines this. Guys, the first term was, help me out here. I got a mess going on here. If you expand this out, is there an x to the 4th coming out for the first term? With that coefficient. 1 over, what was it, 174? Okay, 1 over 174 x to the 4th. And that's what my end behavior would depend upon. Yes, no? Now Now this one says, please replace x by large numbers. Common sense tells you, if you replace x by a large number, and you raise it to the fourth, it will get much larger. Times 1/4 positive stays positive. The result's gotta be this. If you go up and replace x by a negative number, on this, raise it to the fourth, it's going to turn to a positive. Times that positive 1/74 stays positive. Infinity. Is that true? Okay, so we got the x-intercept, we got the y-intercept, we know the end behavior. Now right now, the end behavior is a professor, what end? Well, the way it looks, I have just this to worry about on this end. I just have one x-intercept, so that means out here on this end, it must be doing this. Would you guys agree? Then on the other end, to the left of 4, can't do much with it. Mr. Park says it goes through that y-intercept, and the graph looks something like that. That make sense? Okay. And by the way, did the graph touch at 4? And I think back here we said it was a multiplicity of what, 2? So it should touch. Yes, Isabel.
Does negative 2, 6 not help on the graph? Or
Do we get now?
Negative 2, 6. A point?
Ah, beautiful, beautiful. Look at this. She's a professor. Now you got a rough sketch, and I'll accept this right here. She's good. She's a professor. If you go out to a negative 2, and guys, I know my graph can be stretched out some. If you think you could validate that out negative 2 up 6 may fall on this red graph? Is that true, guys? In fact, it should, based on something we did back here. So out negative 2 up 6 should be on there. It's on there. Whew. Domain, negative infinity or positive infinity. Range, oh, what's range? What's my up and down? 0 through infinity, including 0. Bracket 0. Is that true? And it touches only, my graph should it's touching right here, 4. Okay. Now, can we do something like this on the quiz Wednesday? Well, I may give you information, you gotta put that information together and go from there and get all this done. Guys, that was a nice problem to start out with, just for a little recap. I think it works out well for us. Let me leave that strange graph. Who would think? I would think that if someone kept me surrounded, here's the function, either this or this. You think I could quickly just standing there say, oh, it looks like this? No way. I just look at myself closely and see if it looks like that. It looks somewhat like parabola. It's not a true parabola. Okay, guys, we're done with that? Now, what I gotta do, be very, very careful on this. By the way, if you mess up, and my example today had a strange A value. If you mess up on that A value, you make some arithmetic mistake in your work on Wednesday. That's why this quiz is more demanding. And let's go throw things off. So be very, very, very careful. Lots of other places here you can be thrown off. Okay. Now, with that said, I got a handout here for you shortly here. Let's see if I'm ready for the conclusion of chapter 3 here. Oh my goodness. Okay, guys, I'm just looking at things here. Okay. I'd like to see this. A little recap on something here. We'll give you a function, p of x, part 2, let's say. Part 2, I'm giving the function to you. You don't have to find the function this time. So we'll say given this function, p of x equal to negative 1/3 x plus, looks like x plus 1 it is, squared, times x subtract 6. grid. I don't think, you see one of these, I don't think there's gonna be much of an issue on these. And guys, if it's given to me in that form, do I see right now the x-intercept? They're called zeros. Do I see them right now, just based on what you see here? If you look at the factor x plus 1, that's going to lead me quickly into, Professor, there's one at -1. There's a 0, x-intercept. If I look at 6, I get 6, let me go out to 6. It says right there, another x-intercept. Since I'm talking about x-intercept, let's pick up the y-intercept, just in case I need it. Y-intercept can always be found by doing this, find p of 0. Guys, if I replace all those x's by 0, I don't think this one's going to be too bad. I think you end up with 1 and a -6, I think. Is it true? And then do the math there, and I think it'll be a positive answer, like a +2. Now, I'm on top of the board here, guys. So it looks like implied here is 0, 2. That means up to, get ready for it, it's a y-intercept. Now, since I'm asking for sketch, got the zeros, I have the, I'm going to now look at the cross touch in behavior. Let's get the in behavior out of the way. Guys, by the end behavior, that depends upon the very first term. Now notice this one's not multiplied out for you, but I think if you expand it out, you're going to end up with what? -1/3, I'll jot that down here, x to the 3rd. Do not let me mess up here, is that true? That -1/3, x to the 3rd. And then you answer these two questions for me. Limit, as x is approaching positive infinity of this function. It all depends on what this thing's doing. So if we replace x there by a large number and cube it, gets larger, times the -1/3, turns it around to a negative, it's a negative infinity. On the other end, x is approaching negative infinity of this function. That all depends on this first term. Replace x by a negative number, cube it, of course get a negative. Times that -1/3 out front makes it positive. So the result will be a positive infinity. And I think that might be enough, and we'll look at the touch cross when I get started here. Let me get that in behavior out of the way. Out on the right, oh, interesting. It's doing this, on this end. On the other end, it looks like it's doing this. The end behavior's done. Now, my zeros. I notice the -1 came from this factor, which has the next one of what, 2? So if it's an even, it should do what? Touch. Now when it touches here, it bounces back, in other words. It's got to go through this. It may go directly through it, who knows? It's got to come back and eventually connect with 6. And then it should cross at 6, which looks like it should by the function there. And there's the graph. How can you go wrong? Well, that's the graph. Now, the domain, negative infinity through positive infinity always, that's the answer for the domain. Range, why might I not be able to in math 2 ask you about the range here? Or, hold on, oh, I can. What is the up and down described as for the range? Is it dropping down forever? Or is that negative infinity? Positive infinity, all real numbers for the range, and also for the domain. Now, the reason I brought this one in, here goes, just listen carefully. It looks like there's a minimum value right here. A local min, if you wish to call it, or an absolute min, okay? In fact, the value, I see the value of that min is 0, the way the graph looks. Also, looks like somewhere in here might be a max located somewhere, okay? Maybe a local max in there. So it looks like I may have a local max somewhere in here and a local min here, which is clearly seen. How many extreme points, they call them extrema. How many extremas do I have here? That's max and min put together. Do I have 2? Have one of each. The rule says, go back to your function. If you were to multiply this out, guys, I'm gonna end up with an x cubed. Back to -1/3 x cubed. If you should expand that out. Look at that, the degree. You wanna look at the degree? The degree in this case is 3. The rule says you can have for these turning points, we call them turning points. And you have the number of turning points at a max to be 1 less than the degree. So if my degree is 3 in the original function, 1 less than that is 2. And in fact, we lucked out here, did I get 2 extreme points? And they call them turning points. So you subtract 1 from the degree to see at most how many turning points could you have. You may not see all of them. In this case, we lucked out, we saw both. So we got 2 here. The number of turning points, n minus 1, they call it n minus 1, guys. The degree minus 1. It'll tell you the number of, max number of points, turning points. Maximum number of turning points. Other than that, that's why I showed you that. Make sense? Now what else is there? I'm looking through my notes, I think that's a good recap right there. It took a little time to do this. Now, with that said, I don't want to scare anyone. I did write myself a little note here. I'm asking my students to send me copies of tests that they're taking now at universities. Account tests. Okay? I saw, and this maybe on one of the handouts I gave you guys, I saw a function like this on one of the examples sent to me by a student, where they were doing some calculus on it. Just jot it down, just to scare you. Like that. Before I leave this. And we step to the side and look at it, make sure it's copied down correctly. It looks good. Sure does. I suppose you walk in Wednesday and you see that. You see that? That's your quiz problem. And you know what I'm gonna ask? I'm gonna ask you to find the 3 zeros. Now, the 3 zeros of P over Q and all that business, were we doing the P over Q yet on this? I don't think we tried a P over Q yet, have we? No, so you're gonna go through all that process of P over Q, start testing my synthetic and hope that something works. Now, this one's interesting. Guys, if I try P over Q, rational zeros theorem, where the P is supposed to be a factor of what, my constant term, not too many factors there for -2. I'm writing in combined form. The Q should be a factor of the leading coefficient, which is understood to be a 1. Well, I'm even shorter there. My goodness, wait, that thing is so lengthy. That's all I have to work with? Please tell me, I'm on top of the board here. Did I write those things down correctly? And you say, wait, Professor, I'm desperate here. You're asking me to find the 5 zeros, Professor, on my quiz. And I know now to do this, jot down my coefficients. All this is a little recap, but 1, -5, 11, -13, 8, -2. I got all that copied down correctly. And when I saw this, I thought about Jonathan, and four o'clock session, Jonathan was asking me a question. Michael told me something in class last week. Seems like he always starts with testing 1, right? So I thought about you. And Jonathan, I thought about something you said in the 4 o'clock session. Guys, if I test 1 right now, what happens? Now sometimes we look out. Place a 1 here, start with the synthetic. Now if I start it, 0, 1, 1, -4, -4, 7, 7, -6, -6, 2, 2. I did that so quickly. Did we get a 0? How many zeros am I supposed to get all together? 5. Well, Michael, your 1 worked. Now, we don't have very many more numbers to test. Does someone see something else you'd like to test? And if so, I'll stack it up. I would do this though, if it would work for me. I said, wait now, Professor, in the red here, those leftovers. After I found 1 answer to work, I found a 1, and I was looking for 5. I'm now down to 4 that are remaining. So these remaining numbers must name x to the 4th minus 4x cubed plus 7x squared, subtract 6x plus 2 is equal to 0. That's true? Now, I don't think algebraically, I'm looking at myself, I don't think algebraically I can do anything to it. Does anyone see grouping or anything to be done with that? I don't think I can do it, can I? I just want to group a little bit. By the way, you guys, do these remaining numbers in the red name this? And I can't do anything with that one. I was hoping I could group and do a little algebra and not do additional testing. Unless someone sees something I'm not seeing here. So, yeah, I'm going to group. Group here. Now what? I need more answers. More zeros. What do you think? Guys, you can write this out. Now, by the way, if you want to write this out, and it's not a factor, you could start P over Q again on this. And go from there to do it. But I was hoping it would factor. It's not going to factor. So I'm looking for my 4 remaining zeros, and I'm stuck. Anyone have an idea? Other possibilities here, guys, would be 1 over 1, a -1, 1, 2, -2. I don't think I've tested 2 or -2, and I don't think I looked at Descartes' rule to see how many zeros there should be. Just out of curiosity, real quickly. I see 1 sign change, another sign change, another sign change, a sign change, a sign change. I think. Were there 5 sign changes? So by Descartes' rule, those 5 zeros all could be positive. Or 3, or 1. Reduce it down by 2. So 5 positive altogether, or it could be 3 positives and 2 whatever, or it could be what? 2 zeros that are positive. Negatives? Look at this. We're desperate here on this crazy problem. If you replace x by -x, I'm going quickly. Replace an x by -x, raise it to the 5th power, you're going to end up with that. Raise it to the 4th, it stays positive, but that -5 up front makes it look like that. Cube it, that's going to be a negative. -11x cubed. And then down here, squared, -13x squared. -8x. Subtract 2. Is that true? I did it quickly. How many sign changes do you see there? None. I don't see any sign changes. So those 5 zeros, am I expecting any negative zeros at all? So no test of negative. Now, there you are staring at this, you're staring at this. Guys, you can test 2. I'm gonna tell you ahead of time it's not gonna work, just to save you a little time. Oh my goodness, that's the only other number to test. Isn't it? There are no negative zeros here, but Descartes' rule, 2 is the only other possibility. To save me a little time, 2 is not gonna work. Okay, does anyone have an idea? Or why would I bring this in? You get desperate. Now you're gonna find the other 4 zeros. I mean, was it 4 or 5? I got 1 here. Okay. I got 4 more zeros.
Can you
She thinks one works again. If it does, let's see if it does. 0, 1, 1, -3, -3, 4, 4, -2, do not let me mess up here, -2, oh, you're kidding. True? Brianna, what do you have in mind now?
Hopefully a group, so.
Okay, now you could, you say, wait, Professor, maybe now this time it groups, and I'm telling you ahead of time, I don't think you write this out, I don't think it's gonna group. You can try, I don't think, staying here and just looking at it, I don't think it's gonna group.
Try one again.
He says, try one again. 0, 1, 1, -2, -2, 2, 2. Are you kidding? I did it quickly. Jeez. If all that's done correctly, guys, I have for my 5 zeros, right, this one I have, Brianna's help, 1, a multiplicity of 3. Showed up 3 times. Now, I'll take her advice on this. I'm down to, looks like maybe a quadratic. If I take these remaining numbers and name that quadratic, I have 1x squared, subtract 2x plus 2. I can solve that myself by quadratic formula. Here goes, by quadratic formula, we end up with a 2 plus minus square root. Looks like underneath there it's going to be a 4, subtract 4 times 1 times 2, getting really crazy on us, over 2. Step back and look at b squared minus 4 times a times c looks good. So it's going to be a 2 plus minus. Underneath there is 4 subtract 8, that's a -4. Are you kidding? Over 2. What's the best I can say for square root -4? 2i. So it's 2 plus minus 2i over 2. Reduce this thing down by 2, divide everything by 2. You're going to end up with 1 plus minus I. Lord. That means this. 1 plus I, 1 minus I now have all 5 zeros. Now, what would help you as a student? So you would not sit there and take 35, 40 minutes on this one problem. What would help you that maybe your instructor could do for you ahead of time that may help you save a little time on this? What can I do for you? I say find the zeros, and I could make a little remark, and what would be a nice remark for me to put on there, if I should do it, to save you from sitting there and sitting there and sitting there and think, oh my goodness, professor, tell me 1 works 3 times. What could I say for a little remark on the quiz to save you a little time? There's something simple like there is an answer or a 0 in multiplicity. If I said a multiplicity 3, that's a giveaway. Now, I may just say there is a 0 of some multiplicity. So that means it's going to work more than once. That may save you a little time. But I put that warning on the quiz, you may not know. Then you overlook it. Okay? Guys, it's done. Let's put this thing in factored form. P of x, look at this crazy thing here. P of x down here. Now with what I have here, I got 1 multiplicity of 3. That's x minus 1 cubed. That's no problem. Be careful here. They're conjugates. So to get 1 plus I will be x, where am I getting? Minus 1 minus I. And to get the 1 plus I, looks like it's going to be x minus 1 plus I. Let me step to the side here. See if you guys agree. Is that true? Better yet, if I say do not leave an I, you're going to write it like this. X minus 1 cubed. I'm not going to ask you to fully expand it. But I need to multiply these 2 together, and I think the best process to multiply those 2 together to get rid of that I, this is A minus B, and this is A plus B. That's the form it takes. Of course, we all know from middle score, as I said before, is that. That's a fast way to find what the product is on the end. So guys, we end up with x minus 1 squared minus I squared, which I think was over here somewhere. If I do this, x squared minus 2x plus 1, I squared is negative 1, it's going to turn into a plus 1, x squared minus 2x plus 2. And I think the way we did this, we had here, just to confirm. So guys, my other factor would be, let's try to find where I am. Oh, right here, is x squared minus 2x plus 2. And there it is, in factor form, no I, the one right above it has the I. Does all that make sense? Jeez. Now, the last part of chapter 3. I hope that you're enjoying polynomial functions. But we'll go around into semantics. Chapter 4 closes down with a different type of function altogether. Rational functions. We're not going to see Randy do one as quickly or as much detail, or in fact, I'll have more detail than these. Okay, so these will require a little bit more detail, a little bit more thought on what's going on here. Chapter 3 is going to close down with this. Now, I thought the best thing for me to do is give you the handout. I have 4 examples at the bottom of the handout. Then I thought to myself before I came to campus, so hold on, let me practice with my class, let me give them 1 here. And we'll go through all the steps required. Then all of a sudden, flip it over, and there's the answer. There's the graph. Oh wait, if you look at this graph, you can see it from back there. See this graph? This is not continuous. This disconnected. Discontinuous. These functions will be discontinuous. They're not like these. Okay? So I think I'm gonna do this first. On the handout, yes, I have steps to follow. You see a rational function. That's where they go time. And then I have a few examples I said down here, but I think before I jump into these examples, I may do 1 or 2 of these examples, then do the one on the other handout. Mr. Park, help me out here.
Yeah.
Are you leaving us soon?
Thanks.
I mean, yeah, any other schools? Have you heard from anyone?
Not yet.
What made you think that maybe the 1 worked again? Just, what the heck, I'll try 1 again.
Well, I just figured there's some with multiplicities.
There you go, And keep 1 for yourself. Okay, guys, I think my time here. I need some help